Welcome to the lesson Physical and Chemical Changes, where you'll investigate the different ways that matter can change. In this lesson, you'll learn to recognize the difference between physical and chemical changes. The vocabulary words for this lesson are physical change, chemical change, and law of conservation of mass. Fireworks are a dramatic example of a chemical change. Not every change in matter is as exciting as fireworks. Still, you see and use many changes of matter every day. Physical and chemical changes can sometimes be difficult to tell apart, but it helps to know exactly what physical and chemical changes are. Click each image to learn more. A physical change is a change of matter in which the identity of a substance does not change. Cutting paper is a good example of a physical change. Dissolving sugar in water is another example of a physical change. Sawdust produced by cutting wood is another example of a physical change. So is molding a piece of clay into a pot. The clay is still clay, even though its shape is different. Changes of state, such as the change from a liquid to a gas or from a solid to a liquid, are also physical changes. Now, let's look at some chemical changes. A chemical change is a change of matter in which one or more substances becomes a new substance or substances. Rust is an example of a chemical change. Rust is a product of a chemical reaction that takes place when iron combines with oxygen. The result is iron oxide, or rust, which is the product of a chemical change. Another example of a chemical change is the burning of a substance. Ashes and gases are formed. Another example of a change is digesting of food. That's because the food breaks down into nutrients that the body uses to live and grow. How can you tell if a chemical change is taking place? There are different forms of evidence that show that a chemical change might be happening. Click each picture to learn more about the signs of a chemical change. Fizzing, bubbling, and foaming are signs that a gas has been made during a chemical change. Sometimes new solids form during a chemical change. Observe what happens when sodium chromate is added to silver nitrate. That is called the production of a precipitate. Both substances are clear solutions, but together they have given off a colorful solid. Some chemical changes, especially burning, give off thermal energy or heat. The methane in natural gas burns with a bright Flame. Do you smell that? A new odor often indicates that a new substance has been formed. The smell of a pie baking is one example. A change in color is another sign that a chemical change might be happening. As bananas ripen, the peels undergo a chemical change that makes it turn brown. A chemical change that gives off energy might produce light and sound, just like the fireworks from the beginning of this lesson. Chemical changes are affected by temperature. Have you ever used a light stick? A chemical change inside a light stick produces a bright glow that can last for hours before slowly fading out. Click the labels to learn how temperature affects their chemical changes. Lower temperatures can cause chemical changes to happen more slowly. Lower temperatures cause chemical changes to happen more slowly. The light stick glows much less brightly in cold water. Higher temperatures cause chemical changes to happen more quickly. The light stick glows very brightly in hot water. The law of conservation of mass states that mass cannot be created or destroyed in ordinary chemical and physical changes. In other words, things cannot appear out of nowhere or disappear. Click on each picture to learn more about the law of conservation of mass in physical and chemical changes. Mass does not change in physical changes. This metal, called gallium, has a melting point close to room temperature. When substances melt or evaporate, they may appear to lose mass, but if you measure the mass after the change of state, you'll find that the mass is really still the same. The law of conservation of mass applies to chemical changes too. This photo shows the mass of the reactants before a chemical reaction happens. Click the next image to see the mass after the products are formed. The mass of the products of the chemical reaction is the same as the mass of the reactants. Sometimes mass appears to be lost during a chemical change in which a gas is produced. But if you measure the gas that is released, you'll find that the total mass does not change. Sort the images into physical or chemical changes. Drag them to the correct locations. Good job! Keep in mind that a physical change of matter is a change in which the identity of the matter does not change. A chemical change is a change of matter in which one or more substances becomes a new substance. Select the signs of a chemical change that are present when bread is baked. Click your answers. That's partly correct. You've probably noticed that bread smells really good when it's baking. That change in odor is a sign that a chemical change has taken place. When the bagels turn to a delicious golden brown color, it's another sign that a chemical change has taken place. Two solids and a liquid combined in a chemical change. The mass of the final mixture is lower than the mass of the starting ingredients. What happened to the missing mass? In a physical change, chemical composition stays the same and no new substances are formed. Matter does not change identity during a physical change. New substances are formed during a chemical change. The new substances formed have different properties than the properties of the original substances. Signs that a chemical change include a gas, a production of a gas or solid, production of light, thermal energy or sound, and a change in color or odor.